Welcome to the AMATIC 2015 webinar series, taking the guesswork out of writing better multiple choice questions with Dr. Patricia Gregg. And this presentation is sponsored by the Placement and Assessment Committee. AMATIC is the American Mathematical Association of two-year colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness as a personally initiated lifelong responsibility. And for more information, please visit our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by the presenters are not endorsed by AMATIC. And today's webinar is sponsored or supported by Webassign. So Webassign is proud to support the AMATIC webinar series this year. And so now we're going to switch to the presenter slides. And I'm not going to thank you for participating in the webinar quite yet. I apologize, my screen is still flickering in and out for some reason. So I'm going to bring up Patty's slides here. And so while those are coming up, let me just introduce Patty real quickly. So Dr. Patricia Gregg is Associate Director for Assessment at Georgia Perimeter College in the Atlanta metropolitan area. Patty's 30-year career in higher education includes both undergraduate and graduate teaching, research, and administration. Her current responsibilities center around program evaluation, accreditation, quantitative and qualitative data analysis, and numerous committees. She has chaired GPC's General Education Outcomes and Academic Assessment Advisory Committees. Patty holds a bachelor's degree in education from Boston University, an MBA from the University of South Florida, and a PhD in higher education from Penn State, having conducted her dissertation research in the United Kingdom. She is currently the president of the Georgia affiliate of the Association for Institutional Research and has presented at regional, national, and international conferences. While not a mathematician by training, she has worked closely with the Math, Computer Science, and Engineering course committees at GPC and was invited to deliver the keynote address at the 2013 GPC Mathematics Conference. And so without further ado, if we could all please welcome Patty in the chat room, that would be great. And I'm going to turn it over to you now, Patty.
Thank you very much, and thank you for that kind introduction. And also, thank you in advance, John, for monitoring the chat room. Almost all human beings are not as good at multitasking as they think they are, and I don't even pretend. So I am going to focus my attention primarily on my presentation, and hopefully somebody will holler at me literally or figuratively if I need to address something in an urgent manner. So, John, you need to remind me how I advance my slides. Oh, there it is. Never mind. So, the first thing I want to say about writing better multiple choice test questions is that the first thing we have to do is make sure that a multiple choice test is the right instrument. I think we overuse them in higher education in the United States, and there are a lot of other options for assessing student learning. However, that being said, I think that math courses, and particularly math courses that we teach at the first 2-year level, probably have more learning outcomes that are appropriate for multiple choice testing than many others might. So this slide is a word cloud made of the verbs from the student learning outcomes in all the math classes we teach at GPC. I took all the Common Course outlines and gathered all the student learning outcomes, and these were the verbs that we proclaim we want our students to achieve when they complete our courses. for the most part, the ones we emphasize the most can be assessed with a multiple choice test. And I'm going to see if I can use my little pointer here. John tried to teach me how to use it, so I hope it's working. Oh, there it is. So use, solve, apply, determine, define, calculate. These are all things that we can absolutely assess with multiple choice testing. Some of these others, analyze, interpret, those get a little more challenging, but they can actually be assessed with multiple choice questions, and we're going to see some examples of that a little bit later on. This one I dislike very much. I'm not sure what it means. I wish we wouldn't use it, but we tend to use it a lot, probably more in other disciplines than in math. Some things that can't be assessed with a multiple choice test question: prove, graph, make. If we're talking about creating something, then I think create is here. It's teeny tiny. We don't say that that's something we want our students to do very often, but those are the kinds of things that we need other instruments for. Your colleagues in the liberal arts tend to love verbs like explain and describe, and I like for students to be able to explain and describe things also, but a multiple choice instrument is not going to be the way that we can assess those particular skills. So with the understanding that we are here today to talk about writing better multiple choice test questions, here is some general information that is gleaned from the literature, and I will say that not all of these recommendations are pertinent to math. Some of your questions are going to be constructed a little differently than the questions of your colleagues in the humanities and the social sciences, and even the natural sciences might be. But generally speaking, it's all about trying to make the question as clear as possible to the reader. We want the reader to have a clear indication of what the question is about. It's helpful to phrase it in the form of a question, not using incomplete statements, fill in the blank, that type of thing. You want to be consistent with your grammar and syntax. Don't give clues about the right answer based on the wording of the stem. We're going to see some examples of this a little bit later on. Try to avoid convoluted constructions and a lot of negatives. Using scenarios is good, the dreaded word problem, but don't make them too long. Don't include a lot of distracting or irrelevant information. Now, why do we recommend these things as good practice? Particularly, they're good practice at any level and for any type of student, but especially at two-year colleges. We have a disproportionate number of non-native English speakers, students with learning disabilities, students with ADD. We've got a lot of returning veterans now who are coming back with various kinds of brain injuries and neurological issues. And this population is very vulnerable for having challenges related to reading. So we want to be sure that the skills that we're testing are the math skills and that we're not testing reading comprehension. That's somebody else's job, and blissfully we don't have to deal with that. As an example, at GPC, 18% of our student body are non-US citizens. Now, some of those non-US citizens are indeed native speakers of English. They come from countries where English is spoken. But we also have a number of students who are US citizens who may not be native English speakers. So it probably averages out pretty well that close to 20% of our students are non-native English speakers. Same thing with our answer options. We want to have categories that are mutually exclusive. We don't want the answer categories to overlap. We want to have one clear right or best answer. We want to try to avoid the all of the above, none of the above, both A and C type of answers. And that may be different for some of you. That may not be the way that you were taught or tested, and you may think that that is helpful for kind of varying things up and keeping the test interesting, but it actually tends to confuse readers, and it really doesn't test what we're trying to determine. We're not interested in knowing whether students can recognize the wrong answer. We're interested in knowing whether students can derive the right answer. So again, with our answer options, we want to be consistent with our grammar and syntax. We want to try to make our answer options the same length and construction. Sometimes when we're, particularly not necessarily with numerical solutions, but with verbal information, we might be giving a textbook definition. So the other wrong answer choices might be longer or shorter, and students are going to be able to quickly pick out the textbook definition that is phrased differently. Sometimes students will either go for the longest answer or the shortest answer because they think that may be the right one. And last but not least, and this is the one that we'll talk about in some greater length, your answer options should be equally plausible. We don't want any obviously wrong answers. So invariably comes the question about plausible distractors. Isn't that trick questions? Aren't we making it harder on our students? The answer to that is no. Plausible distractors help to minimize lucky guesses, to ensure that we're really measuring students' learning, not their ability to recognize blatantly irrelevant information. And most importantly, and most useful for your purposes, especially with teaching entry-level math courses, is to diagnose key concepts that students may be misunderstanding or confusing with one another. Now, whenever I give a presentation like this and whenever I talk to faculty colleagues at GPC, I invariably hear that if students can rule out one answer as completely wrong, they can narrow down their choices. It helps them to be a little more successful on the test. And my response to that, and particularly with you folks, you're mathematicians, you understand probability. If you want to give your students a 1 out of 3 chance of guessing correctly, just give them 3 answer options. Don't give them 4 with one blatantly erroneous answer or something that they can very swiftly and easily rule out. So I'm going to stop talking for a second, take a drink of water, and see if there are any questions about what I've talked about so far before I move on to a new topic. All right, somebody's typing, so I'm going to wait just half a second and see if what they're typing is germane to what we have just covered. Maybe I'll come back to it after we take a little survey. So John, this would be your cue to put up the first poll. Okay, so I think everybody has taken the poll well. That's not
Yeah,
too...
Patty, I think that we haven't had that many responses, and I'm wondering if maybe you could expand upon item analysis for some of the people who aren't sure what the question is asking about.
Well, actually, for the purpose of this poll, I'm going to say that if you don't know what item analysis is, then you probably aren't using it regularly. So I would probably just consider that as a never answer.
Take your cue to when to end the poll, because I don't think too many more folks are going to respond.
So now, do I do this broadcast results, or do you do that? There we go. So that means everybody can see now what the responses were. So a couple of people are doing item analysis whenever they create a new test, and a couple of people are not doing it at all, and a few people are not sure what item analysis is. So that's excellent, because I'm now going to tell you. And I guess, John, you can take that down. Thank you very much. So item analysis can help you to understand which of your incorrect answer options are indeed plausible distractors, and whether your test questions are effectively discriminating between your high-performing and your low-performing students. And there are a number of applications out there that do item analysis. I am not advocating for any one particular software package. If you have a learning management system at your institution, there may be some item analysis built into your LMS. GPC uses an application called ParScore, which is a Scantron product. We are happy with it, but there are, I'm sure, many competitive products on the market that are equally as good. So this printout is a ParScore report. And again, whatever software package you may have, your report may look slightly different from this, but the same basic information is provided. And so the report is going to give you the total number of correct responses, and then it's going to give you the correct responses for the upper quartile and lower quartile. Now in ParScore, rather than using 25%, they use 27. I'm not sure why they do that. You mathematicians may know some sort of statistical reason why that is more valid. I have to tell you that when I talk about this information with people from art history, that really confuses the living daylights out of them. I wish it really were a quartile, but nevertheless, the basic idea is that we're looking at the difference between our top performing students and our bottom performing students. We will get a measure called a point by serial correlation, and this is a measure of how well the test discriminates between those two groups. Generally speaking, in the literature, anything above a 0.3 is considered a strong point by serial correlation. The higher is better. When you have point by serials that are below 0.2 and certainly below 0.1, then you have a reasonable expectation that your test item is not a strong item. So on this particular example, if we look at these circled items here, numbers 1 and 2, we can see that these are pretty good questions. Even though overall the students did not do well, I think this actually really was a math test. We can still see a significant difference between the high-performing students and the low-performing students on each of these items. We can also see that most of the response categories, not categories, most of the response options were plausible distractors. We had actually, in this case, more students selecting the wrong answer options than the right one. Even though answer option A here was technically not a non-distractor because 4 students selected it, I would argue that when you've got an N of 410 and you have only 4 people who selected this answer option, it was probably pretty blatantly obvious that it was not correct. And we might want to beef that one up. Yes.
There's a couple of questions about, one of them is, how is the point by serial calculated? I don't know if that's a technicality you want to get into right now or not, but that did come up.
Yeah, I see that now. It actually is not a technicality I want to get into. You all being mathematicians can probably understand the derivation of that statistic better than I can. If you search on point by serial correlation, if you put that search term into Google or Bing or whatever you use, you'll find lots and lots of articles about it. Generally speaking, I use it as an indicator of the strength of the question. It's looking at the difference between the students in the upper quartile and the students in the lower quartile, and that's as much depth as I really plan to go into about that. So if we look down here at answer options 8 and 9, or test questions 8 and 9, we can see that these were weaker questions. The point by serial correlations are a little lower, and we have one complete non-distractor. Absolutely no students out of 410 selected answer option D on question 8, and only 5 selected answer option C. And the same thing down here on question 9, we had very few students out of 410 who were selecting those options. So they probably were not really plausible distractors. So this report, this kind of report, can give you an indication of whether your test items are effectively discriminating and whether you are really testing what you hope that you are testing. I've got another example here. This is a different test. It was definitely not a math test. I think I remember what discipline it was from, and I'm not going to call anybody out on that. But you can see here that students did universally well on this test, and the difference between the high-performing students and low-performing students was almost non-existent. When you have items where 97% of the entire class is getting it right, you're not going to see very much discrimination there. Moving down, we have a couple of items that did a slightly better job, but overall, this test was probably not targeted at the correct level. We were really not testing the learning outcomes that we intend for our students to know and be able to do in this particular class if we have this kind of performance on the test. We also can see that we have a large number of non-distractors for a lot of these items. Now, my guess is, I don't have a copy of the test in front of me, and I don't remember the exact situation. Chances are that every test question did not have 5 options. And so the reason we're seeing zeros in that option E column is that that item may not even have had an E. ParseScore likes everything to match. So if there is an option E on some questions, then we need to include it on all of the others. But there are clearly some other questions where several of the answer options were non-distractors, and that is confirmed by the performance of the students, where we've got better than 90% of the class getting the test items correct. All right, so now that I have sort of kind of almost explained item analysis and shown you an item analysis report, apart from the question about how the point by serial correlation is derived, are there any other questions about item analysis before I move on? Would I recommend getting rid of or changing the non-distractor answers? Yes, that is exactly what I would recommend. You want your answer options to all be plausible distractors, and hopefully you want them to help you diagnose what concepts students are confusing with one another or not fully comprehending. So I would absolutely recommend that you would use your item analysis to determine what test questions in general are not clear to the students and what answer options are either too blatantly easy or possibly too ridiculously difficult. When you've got a test item that only 20% of the class can get right, and only let me go back here for 1 second. When you had a test item that only 39% of your best students got correct, then that may be an indication either that test item was a little too difficult, or clearly that's a concept that needs to be hit a little harder in your class, if that is something that you truly expect your students to know and be able to do. So another question that often comes up when we talk about multiple choice testing is whether or not we can test higher order thinking skills with multiple choice questions. And the answer is yes, we can, but we need to be mindful to ensure that we are really testing the learning outcomes that we proclaim to be seeking. We often claim to be assessing application, analysis, interpretation when we're really assessing recognition, computation, or calculation. Now, in your classes, that may be entirely appropriate, and that's fine. Just be sure that the learning outcomes match with the test items. So if we do want to test higher order thinking skills, the kinds of things that we need to ask our students to do is not to perform calculations or recognize a correct calculation, but to interpret data in numerical form or in graphical form that we've provided to them, to recognize spurious conclusions, to distinguish between relevant and irrelevant information. Those are the kinds of things that we would need to put on a test if if we're really trying to get up to the higher levels of Bloom's taxonomy or learning pyramid or whatever you might want to call that kind of hierarchy. All right, so now what I want to do is work through some examples that I have taken from the literature and found online. And as requested, I have a lot of examples from other disciplines. And of course, for this presentation, we're trying to focus our attention on math. So here's an example of a fairly low-level question, and I will tell you right now that most of my examples will be fairly low-level questions because I'm not a mathematician. So, and I also don't have the kind of software or either the kind of skills, probably more the latter than the former, to do a lot of formulas and do any kind of diagrams. So I don't have those kinds of questions in my examples, but hopefully my examples will illustrate some fundamental points. So we have this test item. Blank triangles have 3 sides of equal length, and then we have our answer options. And this is from that don't be column. Leading with the blank is an awkward construction, especially for anybody who's reading challenge. And about the only thing that would be worse is if the question started with an blank, and then students could immediately rule out options C and D. And you might say, well, what about using a/an or a parenthesis with an n in parentheses to indicate that it could be the either or situation? And the world won't come to an end if you do that, but I would encourage you to use that type of approach sparingly. Again, it is potentially confusing to non-native English speakers, and what we're really trying to assess here is knowledge of geometry, not reading comprehension or reading speed. So here is one possible rewrite of the question. We've now got it very clearly phrased in the form of a question. Which type of triangle has all 3 sides of equal length? And we've got our same answer choices. It's basically the same question, but the construction is much more familiar. Now, mind you, we're still testing recognition of a simple definition. I would like the question better if we gave 4 pictures of triangles and had students select which one was the equilateral one or any of the choices that we have there. For simplicity's sake, I didn't do that on this particular example, and also this was following the format of an item that was in one of the readings that I'll be sharing with you a little bit later. I do want to call your attention to something here, which is the arrangement of the answer options. And I have them very deliberately in a vertical line. Now, here at GPC and possibly at your institution, there is a lot of pressure to save paper, and people are encouraged not to arrange answer options in a vertical line to save space. And I understand that consideration, but if your test is online, for example, or if you have the flexibility and your institution is not concerned with saving paper and printing costs, I strongly encourage you to use this vertical configuration. When we go across, if we went A, B, C, D, or if we went A, B, C, D, that may be confusing to some readers, and they may transpose the wrong letter onto their answer sheet and get the item wrong, not because they didn't know the right answer, but simply because they weren't following the ABC construction. There are many languages spoken around the world that do not read from left to right, but there are none that I know of that read from the bottom to the top. So a vertical configuration is going to be comfortable and familiar to students from almost any part of the world. Here is another item, and obviously this is from a statistics test. Take a moment to look over this item because we are going to move into a pop quiz.
Do you want me to bring that up now? Okay, I see it now. Okay, thanks.
So I'm asking what learning objective that previous item assessed. And I'm going to go backwards here, if I can. I don't know if I can. Yeah. So just for the benefit of those of us with short-term memory challenges, now you've got the item on your screen, so you can let me know what objectives that item is assessing.
I'm guessing that's everyone who's going to vote.
Yeah. Okay.
I can end it whenever. Okay.
So, yeah. Let's go ahead and call it done and say that we are unanimous that this particular test item is assessing students' ability to define those particular terms. And John, you can go ahead and take that off the screen. And now we will look at a possible rewrite of the same test question. So here we have provided a little bit of context, and we've given us a little scenario, not a lengthy scenario, and we've given a set of scores. And excuse me, I'm so sorry. You will see here that I have violated my own advice regarding the ABCD construction, and I only did that so that I could fit everything on one slide. But I think it's a good illustration also of why the vertical arrangement is more reader-friendly for our students. So in order to correctly answer this question, student must still know the definition of mean. So we're still assessing their ability to define these terms, but now we're also moving on and assessing their ability to calculate the mean. Now, I want to point out that this question is not a higher order question. We're not getting into application or interpretation with this question. It's a straightforward definition and calculation. Just because it's a word problem, just because it's got some narrative, doesn't necessarily mean that we are testing higher order skills. So I see a couple of questions in the chat box that I'm going to try to look at briefly and also ask you before we move on to another topic and another set of examples if you have any questions about the ones that I have shown thus far.
I think, Patty, that I want to make you aware that you probably only have around 10 to 12 minutes left also.
Okay. All right, my stopwatch says I'm at 37 minutes, but I will speed it up. All right. So here's Ruthie, and I'll give you a second to see what Ruthie has to say. And I show this cartoon because as you're designing your word problems, your scenario-based problems, think about whether the scenarios are really relevant to your students. Basically, ask yourself the question, what would Ruthie say about this particular test item? We want our students to see the relevance to the problems that they're solving, to the quote-unquote real world. But if we put too many details in a word problem, then we end up testing reading speed and comprehension rather than math. I've hit that point a couple of times. I won't belabor it here. Here is another example from the literature, and I will tell you that I took it verbatim from another source, which I have cited on the next slide, and so there's some spelling issues that a couple people have called to my attention, but I left it exactly as it was written. So do you have a headache yet from this test item? And what do you think Ruthie would say about it? I think she would say, who cares? So here is a rewrite of that item. And again, we're testing the same level of knowledge, but we've taken out some of the fluff and basically focused in on the information that we really want to see if our students know. Thank you, Julie. And now, this section is probably the most important for your purposes in terms of why we want those distractors to all be plausible distractors, and why we want to use our item analysis to help ensure that that happens. When we have good distractors, we can use that information to diagnose the concepts that students are confusing or misunderstanding. So here is a test item that was shared by one of your colleagues who teaches math here at GPC. And one of the things I like about this test item is that it's related to a subject area that is relevant to a large number of our students. Many students at GPC are health professions majors, pre-nursing, pre-dental hygiene, radiologic technology, things of that area. We're not different than the rest of the country, so I suspect this is true of students at your institution as well. So having this kind of laboratory-related, health-related question does provide some relevance to our students. So that was the question, and I'm sure that wizard mathematicians that you all are, you have already determined that the correct answer was A. But here is how we use those answer options for diagnostic purposes. Answer B was the answer that a student would get if they multiplied 2 by 4 rather than raising 2 to the 4th power. Answer C was the answer that the student would get if they multiplied 2200 by 32, thinking that 2 to the 4th is 32 rather than knowing that it's 16. Answer D was kind of the outlier. A student who selects answer D has no understanding of the order of operations. They're probably taking a wild guess because that number looked dramatically different from the others, but they might have derived something close to answer D if they multiplied 2200 by 2 first and then tried to raise it to the 4th power. However, that answer is not one of the choices. That answer is something in the neighborhood, if I did my calculation correctly, of 375 trillion. It's a number that's too large for the display on my calculator and probably too large for the display on most students' phones. And so it either would be a stab in the dark, or it's certainly a clear indication that students do not have the order of operations down. So here's an example from everybody's favorite test, the compass. And I understand completely that the compass, actually this is from the publicly available online practice test. Obviously this was written for a different purpose than most of us would use in our classes, but I think it still illustrates some valid points. So let's look at this test item as if it were a test question that we were going to use in one of our classes. How could the item be stronger? Do we really need 5 answer options? The compass publishers probably do this to minimize the probability of guessing, but in a real test situation, it's pretty hard to come up with 5 plausible alternatives. And if one of them is blatantly wrong, we may as well have 4 options. Do all the answer options contribute to diagnosis? Seems unlikely that a student would select 0 or 45 unless they had almost no grasp of arithmetic. So they've ruled those out pretty quickly. Does the number of math courses taken contribute to the strength of the question? Probably an unnecessary complication for weaker readers. The skill being tested by this item is the calculation of percentages. That's what we want our students to demonstrate. By throwing in those 6s and 8s and whatnot are really just red herrings for the students. And not only that, but what would Ruthie say? We think we've made this item relevant to students, but we really haven't. We care about the number of math classes students took when they were in high school, but students probably not so much. So here's a possible rewrite. And I did this. This is my rewrite. So this is the same question. The same proportions, the same calculation that students have to do, and giving them the same answer options, but we have simplified the STEM and maybe made it more relevant to students. They may be more interested in the percentage of their classmates that applied to college than they are in the percentage of their classmates that took 8 math classes when they were in high school. Here's another item, and I know we're coming close to the end here. So take a look at this for a moment, and I will go ahead and leave that one up on the screen rather than moving to my next slide. But John, you can put up poll number 2 if you would. Or poll number, you might call it number 3, the last of the poll questions. All right, let's go ahead and close that out. We're running neck and neck here with people who think it's too much information and people who think it's just the right amount. And this is a matter of opinion. That's why this was a poll and not a quiz. There is room for difference of opinion. But my opinion is that it was too much contextual information. I think that the item could be stronger if we eliminated some of the extraneous information, such as exercising 3 times a week for 20 minutes. Now, if this test were intended to measure higher order thinking skills, we'd keep that information in there, and we'd probably add some additional what-if scenarios to the test item. But considering that it's intended to be a calculation question, I think we've probably thrown in a few too many red herrings there. So that's the end of my prepared examples. This resource page will, when you get a copy of the PowerPoint, all of these links are live. I will tell you that these are not oriented to mathematics specifically. These are general resources on test construction. Some of them may be relevant to your purposes, some of them may not. This is me. I do weddings, bar mitzvahs, birthday parties for really nerdy kids. But on a more serious note, if you have specific questions that I have not addressed, I think we have a minute or 2 left for questions here. But if you have specific questions for me and you want to shoot me an email or give me a call, I'd be happy to hear from you. If you have colleagues in other disciplines that you think would benefit from this information, I do have similar presentations with examples from other disciplines, and I would be happy to share those with your colleagues. And I don't know what happened to my little icons are in a different place on your screen than they were on mine, but hopefully when you get the actual PowerPoint slides, you'll be able to read my Twitter handle and my LinkedIn.
All right, well, thank you so much, Patty. And if you all could thank Patty again in the chat room, that would be great. I really appreciated your presentation today, and I'm sure that everyone else did as well. And I see a message from Peter in the chat about a certificate, so that is what I'm going to get to for a minute, if you don't mind, Patty, and then we can come back to additional questions after that, as long as you don't mind sticking around for a minute.
Sure,
Let's see.
I don't mind at all.
So let me switch back to the main slides that were up here before. And so thank you again for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/AMATIC. And recordings of past AMATIC webinars can be found at bit.ly/AMATIC-webinars, and it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And to answer Peter's question about the certificates, if you could please take 2 minutes to evaluate the webinar content and the presenter today at bit.ly/amatic29. You can actually click directly on that link. It is a clickable link on your screen so that you don't have to write that down. If you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. So as long as your email address is in there, I will make sure that you get a certificate of participation for today's webinar. And I would recommend just clicking on it right now and filling it out. It really does help me and everyone else here at AMATIC know what you thought about the webinars, and it helps us be successful in the future offerings as well. So again, if you could thank Patty in the chat room, that would be great. And I'm going to actually try to put Patty's information on the screen as well as this link at the same time. And then if you have any questions, please feel free to put them in the chat room, but I'm going to end the official recording right now.
Thanks, John.